video about Avogadro's law. Avogadro's law is another gas law we're going to be looking. And his law in particular deals with two variables, and they are amount of gas, represented by the variable N, and volume, represented by the letter V, which we've seen. We've seen N before also in PV equals nRT, and it means the same thing. It's how much gas you have, measured in moles. So if you notice here, I have a balloon, and I could take this balloon and I could blow some air into it. And by blowing some air into it, I'm basically changing the amount of gas, right? Because gas is coming out of my mouth. Seen here. So this is an amount of gas. Now, let's pretend I blow more gas into here. And actually, we don't have to pretend. I could do that right now. So now we have more gas. Clearly, we see something happen to the volume. Hopefully, you said it increased. That's exactly what Avogadro's law is. It's very easy to understand. Increasing the amount of gas increases the volume. This is a direct relationship. As one variable increases, the other increases. Now, what if I decrease the amount of gas? Watch. I'm going to let some air go. I now have fewer gas molecules inside the balloon. Because I have fewer gas molecules inside, you clearly saw the volume went down. So as N decreased, V decreased. This is also a direct relationship. So let's write that down. As N increases, V increased, direct. As N decreased, V decreased, direct. Both are direct relationships. You can graph that, seen here. This is Avogadro's law graphed. As amount of gas and volume are on your axes, as you increase the amount of gas, your volume goes up. See, volume goes up. This is what a direct graph looks like. Anytime you graph any law that has a direct relationship, you should see a positive upward slope for an increase in the variables, and you'd see a downward slope for the decrease in variables. Okay. Now, what is the relationship seen like in an equation? Here it is. V1 over N1 equals V2 over N2. So if you notice, we have initial conditions and final conditions. This is what happens before, and then there's a change, and this is what happens after. All right? So some things to make sure that you always remember is, if that I'm only changing volume and amount of gas, then I have to make sure I keep temperature and pressure constant. I don't want to take my balloon and go all of a sudden up on top of Mount Kilimanjaro, where the pressure is clearly different and the temperature is different, because that will affect then my balloon. If I'm measuring these two, I have to make sure to keep the other variables constant, meaning keep them the same. Keep them the same. Okay, now let's take a look really quickly at this device seen here. This device is commonly seen in Avogadro's law. And if you notice, there's a little bit of like a plunger seen here, a plunger, or a piston that can move up and down. There's also a tube seen on this jar. Gas can go in and gas can go out. So it allows us to change the N variable. Remember, N represents the number of gas particles in moles. So I can let in more gas, or I can release the gas. Now, if you remember, pressure can't build up, because if pressure builds up, then I have an increase in pressure. So what happens is this device allows gas molecules to go in, and this piston moves up, allowing volume to increase. Or if I remove the gas, the piston falls, right? Less gas, less volume. Pressure never increases or decreases. It doesn't allow pressure to change. It's just the volume that changes. Okay, what's a sample problem going to look like? Let's see here. I have 50 grams of oxygen gas, and it takes up 48 liters of volume. Keeping pressure constant, remember pressure has to stay constant, the amount of gas changed until the volume is 79 liters. How many grams of oxygen are there now in the container? Okay, so how do I know whose law this is? Well, I notice I've got different units here. I've got liters and I've got grams. Grams? His law never had grams in it. So I know that I can take my grams and convert them into moles. So now I know I have moles and volume. Moles and volume, that's Avogadro. Remember, nobody's law has grams in it. So I notice here I can set up my variables. That is really important to do. So let's first start by noticing that we have 50 grams of oxygen gas that take up 48 liters. So initially I know my volume is 48 liters. But I cannot plug in 50 grams in N1 because N1 is measured in moles. You can never plug in grams. Please remember that. So our first step is we need to convert grams into moles. That's our first step, is converting grams into moles. Okay, how do we do this? Well, let's remember. 1 mole equals the molar mass in grams from the periodic table. We've seen this conversion in like the past 2-3 chapters. This is nothing new. So I can use this conversion factor. So I take my 50.0 grams of oxygen. Remember, when oxygen's by itself, it's diatomic Hunkelbrief. And I put the grams of oxygen on the bottom, copy top and bottom unit, in 1 mole of oxygen. I look this up from the periodic table. Remember the conversion? 1 mole equals the mass on the periodic table. 1 mole equals the mass from the periodic table. But remember, you have 2 oxygens. So you have twice as much of the mass. The mass is 16.00 grams on the periodic table. Times 2 gives me 32.00 grams. Good time to pull out my calculator. And when I calculate this, I get 1.56 moles of oxygen. Okay, now that is my initial mole value, 1.56 moles. Since this whole problem is about oxygen, I don't need to label oxygen. It's assumed. Now, my gas has changed, and the volume, new volume, is 79 liters. Okay, how many grams of gas are there? Grams? I don't know how many grams there are, but I know I can figure out how many moles there are, and then at the end convert it into grams. Okay, so I still have a conversion at the end. Let's just think about what his law means, okay? Remember, we said, think about this as being my balloon. If my balloon went from 48 liters to 79 liters, my volume increased. The only way for Avogadro's law for the volume to increase, I must have put in more moles of gas. That's the only way for Avogadro's law for the volume to increase. So as volume increases, we can predict that this mole value needs to also increase. Okay, so this number needs to be bigger. All right, well, let's begin. Let's remember the equation. Bring that back. V1 goes on top, 48 liters over N1, 1.56 moles, equals V2 up on top, 79 liters, N2 on the bottom, and N2 is X. Okay, now, easy for us to do here. We're going to cross multiply. So let's go ahead and do that now. I've got 48 liters times X equals 79 liters times 1.56 moles. Do not simplify yet. Don't simplify the side. Let's keep all of our setup together here. Divide by the 48 liters on both sides to get X by itself. L cancels out with L. Please cancel that out. And now X is going to equal to, now in your calculator, plug in 79 times 1.56 divided by 48. And I get, let's see here, 2 sig figs here, 3 sig figs here, 2 here, 2 sig figs are the least, When you multiply and divide, you want to go the least counted. So I get 2.567, which rounds to 2.6 with 2 sig figs leftover moles of oxygen. Okay, now I'm not done. If you remember, the problem actually asked me how many grams. They might ask you how many moles, they might ask you how many grams. This one says how many grams are there. So now I take my 2.6 moles, and I remember that we're talking about oxygen, O2. And all I have to do now is once again convert it to grams. So look what's coming back once again. 1 mole is equal to the molar mass in grams from the periodic table. I remember that 1 mole of oxygen, O2, has that 32 grams of oxygen. And so I'm now going to take out my calculator and figure out 2.6 times 32 divided by the 1, which is the same thing. And I get 83.2 grams of oxygen. But I check my sig figs. I never look at a conversion factor for sig figs. I have 2 sig figs here. So I need just 2 sig figs. I look next door. That is not a 5 or higher, so I don't round up. So my answer is 83 grams of oxygen. Again, the only reason why I converted to grams in the end is because that's what the problem asked me to. If the problem didn't ask me and it said how many moles, then I could have stopped here with the mole value. You just have to read what the problem says. So let's see. We said and predicted that if the volume went up, 48 to 79, that the moles should have went up. And sure enough, it did. It went from 1.56 to 2.6. Great. So I knew I was heading in the right direction. The only thing was, at the end, I had to do one last conversion. Why? Because they asked me to. How many grams of gas? Make sure you read to see what they ask you for, and that you keep your units on everything. That's the end of the video.